Hello, my dear student. Good day to everyone, and welcome back again to our General Mathematics lecture series number 6. Our focus will be the one-to-one functions. Once again, I'm Agi, your teacher in General Mathematics at Gisad Valley National High School. Before we are going to start, may I invite you to please click the subscribe button and at the same time the notification bell so that when I will be posting a new lesson, you will always be notified. The different objective of our lesson would be focused on, of course, we will determine the inverse of a one-to-one function, represent an inverse function through its table of values and graph. Another would be we will find the domain and range of an inverse function. Of course, definitely, we also include to define or understand the meaning of one-to-one function. So let's start. So for us to understand the one-to-one function, we have to recall the simple definition of a function. It says in here, a function is a mapping from its domain to its range so that each element x of the domain is mapped to one and only one element of the range. So that is the meaning of the function. For us to consider the function to be a one-to-one function, we need to understand this statement. In a one-to-one function, given any value of y, there is only one x that can be paired with a given y. Such functions are also referred to as injective, meaning to say there is a one-to-one correspondence between the domain and the range or vice versa. So that is the meaning of this statement. Another one would be a function is one-to-one if each element of range is mapped from one and only one element of x in the domain. Meaning to say, when we are going to get the reverse, that element of y is mapped only to one element of the domain x and vice versa. Okay? Again, you will notice that this statement speaks of one-to-one correspondence. Okay? I repeat, speaks of one-to-one correspondence between the two elements under the domain and under the range. The next statement would be a function is still considered to be a one-to-one function when it will pass the vertical line test. Definitely, when it passes the vertical line test, the graph will be a graph of a function. But our focus is that a graph is considered to be a graph of one-to-one function? Of course, we make use of another test. Horizontal line test will tell to you that if that horizontal line will intersect the graph of the function in one point, meaning to say that function is considered to be a one-to-one function. Okay? To understand further the application of a one-to-one function in real life is that we have to consider this one. Let's consider this statement. The relation pairing a student to his or her learning reference number. You will notice here in developments, every student has their unique learning reference number. This learning reference number is not repeatedly assigned to more than one student. Okay? Another statement is that the relation pairing a GSIS number to a member. The reason why the pairing of a GSIS number to a certain member is that no GSIS number is assigned to one or more member of the GSIS. GSIS number is uniquely assigned to a specific member. Okay, it is uniquely assigned to a specific member. And of course, the relation pairing an employee to employees number. Okay, the numbers we are talking in here is uniquely assigned to a specific uh, individual. Okay, so that is the meaning of one-to-one function, or shall we say one-to-one correspondence. Which of the two set is a function? Consider this diagram. So you will notice the function f, the domain a, mhat, or shall we say mat, is assigned uniquely to a certain number, 3, 4, 6, 2, and 9. You will notice that m is assigned to 3, h is assigned to 4, a is assigned to 2, and d is assigned to 9. You will notice that there are no repeated assignment of every element in the A and element in the B. So this must be considered to be a one-to-one function. Each y value that is used only once. Another illustration would be uh, M is assigned to 3, H is assigned to 4, A is assigned to 4, T is assigned to D. The question is, would this diagram illustrate a one-to-one function? You will notice that the uh, value of the range 4 is assigned to more than 1, which is H and A, meaning it is not a one-to-one function. The y value of 4 is used more than once, so it is not a one-to-one function. To further understand the one-to-one function, now we can understand this through the use of horizontal line test. But what is this horizontal line test? Please understand this statement. A function y is equal to f of x is a one-to-one if and only if no horizontal line intersects the graph of y, which is equal to f of x, in more than one point. How is this? Shall we say we have in here a function. Our function is y is equal to x raised to 2 minus 4x plus 7. Is not a one-to-one function on the real number because the line y, which is equal to 7, intersect the graph at 0, 7 and 4, 7. Let's try to have this one in the actual illustration in the graph. So we have in here the graph for is the location of 0 and 7. So you will notice in here in the 0, 7 we have to consider this one. So this is positive 2, this is positive 4, positive 6 between this line and this one, that is 7. So our y is 7, and where is our 0? We have in here. So this point has a coordinate of 0 and 7. Another one would be consider this point. So this point is of course correspond to this one, which is y is equal to 7, and correspond to your 4, which is x. So you will notice when we are going to plot this one in a graph, okay, it is a graph of quadratic function. But the point is, the question is this a one-to-one function? Definitely the answer would be no. Why? Because as you can see, when we are going to consider the horizontal line test, okay, now we have in here, see, our horizontal line will intersect the graph at more than 1 point. That is the reason why this is not a one-to-one function, but it is a quadratic function. Determine if the functions are one-to-one functions. Consider this letter A illustration. Y is equal to x raised to 3, or that is read as f of x is equal to x raised to 3. So here is the graph of it. You will notice that if I use my horizontal line test, you'll notice the blue horizontal line, it will only intersect this graph at exactly 1 point. Okay, at exactly 1 point. So how about the other one? You will notice that when I have my horizontal line test, now it will intersect this f of x is equal to x raised to 3 plus 3x raised to 2 minus x minus 1 at exactly 3 points. Meaning to say, the use of horizontal line test uh, fail this function to qualify as one-to-one function. And let's try to elaborate more. The f of x is equal to x raised to 3. So here is the graph of the function. It is considered to be a one-to-one function. Now, why? Because you will notice when I have these 2 points, they are in yellow. So I have in here the first one and then the second one. When I make use of the vertical line test, now it will intersect this graph at exactly 1 point. It is in here. So meaning to say, this x raised to 3 is considered to be a function. Now, again the question is this a one-to-one function? Yes. Why? Because as you can see, it will pass through the test using the horizontal line test. And this line, horizontal line, will pass through the graph at exactly 1 point. Okay? Notice that this function passes both the vertical line test and the horizontal line test. I have in here the statement, a function f is one-to-one if no two elements in the domain of the function correspond to the same element in the range of a function. In other words, each x in the domain has exactly one image in the range, and no y in the range is the image of more than one x in the domain. Okay? Please find time to smile. Okay? Yeah. So again, you can always beat this general mathematics if you listen and try to understand the discussion. Please like, click subscribe button and click the notification bell so that you will always be reminded of the new lesson posted. And again, thank you for listening and good day to everyone.